At its creation, the Earth stored considerable amounts of energy beneath its crust. Since that time, this excess heat has tried to escape. This contained force is partly evacuated by incredible volcanic events called hotspots. Only now are we starting to understand them. They occur when the mantle generates enormous plumes of hot material that rises towards the crust. Here, volcanic activity can last several millions of years. They can appear anywhere on Earth and can create mountains, islands, archipelagos, even entire countries. They change the global landscape. They also have been major players in the evolution of life ever since it appeared on Earth. The gases, ash, and lava that emerge have caused the extinction of countless species. To understand the power and impact that these hotspots can have, we have to go back in time and trace the life of just one of them. The latest one to have radically changed the face of the planet left its gigantic footprint in northwest India. This hotspot began by creating the mountains of Mahabaleshwar that rise above a very old story. This large, igneous province is 65 million years old. The entire range was created from a single, continuous series of eruptions. These multiple layers of lava are stacked more than half a mile thick and extend over a surface area 10 times the size of England. Eroded by time, the sheer cliffs that surround the canyons have become open books to the past. Page 1 was written 65 million years ago. Although the vegetation of the time may have resembled our woodlands, the animal life was wildly different. Dinosaurs and the other giant reptiles had already reigned supreme over the Earth for 200 million years. Their dominance was total and unopposed. The first mammals were unable to compete with these enormous creatures. Dinosaurs and other giant reptiles dominated all of the planet's ecosystems. They had become specialists, each in its own field and in its own environment. Some had become so huge after so many years of dominance that they had to eat vast quantities of food every day. Back then, resources seemed unlimited. The Earth resembled a Garden of Eden. No outward sign foretold their abrupt, dramatic end. A huge meteorite, crashing into the sea off the coast of Mexico, was long thought to be the only disaster responsible for the extinction of the dinosaurs. The impact did indeed kill everything nearby, but on its own, this meteorite would not have wiped out the entire dinosaur population. The fleeing survivors were in fact heading for certain death. For we know today that in this same period, a second cataclysm was about to rage on the other side of the planet. "65 million years ago, India was an enormous island that had just broken off from Africa. It became a continent in its own right and began to drift north. And that was when a major event was going to poison the atmosphere. Huge volumes of magma had just started to pierce the Earth's crust and spread over the surface. The Earth had opened up suddenly to free this excess energy. The dinosaurs had finally met their match, a hotspot. It is difficult to envision such a stupendous event because no human being has ever witnessed a disaster of this scale. Imagine fountains of lava lined up for miles on end and terrible eruptions occurring one after another endlessly. For probably millions of years, India was split open and buried under thick layers of igneous rock. Black basaltic mountains rose high into the air in India, yet it was the entire planet that was affected by the consequences of this tragedy. The colossal amount of magma freed onto the ground from the hotspot released a deadly chemical cocktail into the atmosphere. The eruptions lasted for so long that it is hard to know exactly how events evolved. But we do know that the global climatic patterns were totally disrupted. Fine volcanic material spread out from the ash plumes and into the great air streams. They rapidly formed an opaque veil, plunging the Earth into an age of darkness. Over time, the sulfurous gases reaching the upper atmosphere also had serious consequences. Scattered around the globe, they absorbed and reflected sunlight. For thousands of years, the sky was tinted red by the sulfur, which partially deprived our planet of most of its sunlight. What's more, the steam and carbon dioxide emitted from the volcanoes are greenhouse gases, and once in the atmosphere, they retain the sun's heat and increase the temperature. So the Earth's climatic cycles were completely destabilized for several million years. The seasons vanished, replaced by periods of extreme drought, alternating with endless, devastating rain. Sulfur changed water drops into a lethal poison. Acid rain poured from the sky, burning those that had managed to survive till then. Disaster piled upon disaster. Together with the trillion-ton meteorite, the hotspot swept the world clean of the giants. Debate may still be raging, but the major role played by such an eruption cannot be denied. The dinosaur episode was, however, just the start, for the hotspot had only just been born. It was going to continue to rage as an important page of history was being turned. New life was to rise from the ashes. The creatures able to adapt to the cataclysms of the Cretaceous period then had free rein to prosper. The volcano scenario is irrefutable. The destruction it caused generated a new start. After the disappearance of the dinosaurs, India continued to drift northwards. While the hotspot remained fixed in the mantle, it let the Earth's crust pass by overhead. So as India moved closer to Asia, the hotspot remained under the sea. Beneath the Indian Ocean, it continued to transform the world and toy with life on Earth. Two and a half miles under the surface, where nothing seemed able to live, the heat of the hotspot worked wonders. Lying beneath the deep-sea plain, down in darkness, the invisible pocket of magma heated the glacial waters and began building communities of life. No sunlight reaches this far down. The pressure is tremendous, and toxic chemicals burst from the boiling water. But here, sulfur fuels life. Bacteria developed in close proximity to burning vents, able to survive in water at almost 600 degrees Fahrenheit. Deprived of the energy of light, the bacteria transformed sulfur into edible organic matter, thus becoming the first link in a new food chain. The larvae and eggs of these deep-water organisms drifted in the great currents that swept along the bottom of the planet's oceans, which is how they colonized these very remote oases. They moved from one hydrothermal vent to another. Chance encounters meant that species landed in new clusters, new gardens of Eden, heated by the underground magma. As extreme and improbable as it may seem, an environment created by the hotspot was conducive to creating life. These organisms are said to be species surviving from ancient geological times. These underwater communities are only one stage in the hotspot's odyssey. Like its ancestors, the young hotspot in the Indian Ocean supports swarming citadels of life, whose fate is precarious, for these oases rest upon the tip of a slumbering volcano. The hotspot is still producing magma, which tries to force its way out through the crust. The volcanic process is once again underway, destroying an environment and building a new one. It starts its long ascent to the surface. The hotspot pierces the Earth's crust and unleashes its power. Nothing can stop it. While the surface of the ocean is still 2 miles up, the volcano spews out enough lava to create a first platform. This becomes the foundation of an undersea mountain. As it rises, the volcano's mood shifts. The closer it is to the surface, the less pressure there is, leading to a greater magnitude in the explosions. It stains the water with sulfur. When the erupting magma comes into direct contact with a body of water, the very large contrast in temperature causes both the water and the magma to explode. Miles offshore, the hot spot creates an island. Once an island emerges from the water, a new battle starts between land and sea. The power of the waves collides against the ramparts of the volcano. Its foundation amplifies the swell, and its roof can be wiped out by a single set of waves. The new island can crumble and be dispersed in the ocean. It can vanish several times, drowned by storms, before establishing a headland, a pinnacle or a peninsula that can withstand the pounding of the sea. Yet the magma chamber supplying the hotspot seems inexhaustible. That is its strength. As long as the magma is there to feed the volcano, the island will last, and new virgin land will be available to pioneers. Rain, wind, and sun will bring new energy and present new challenges to the first islanders. Moss and lichen survive on water and minerals that they extract from lava flows. Volcanoes take and give. What was once a force of destruction becomes food. With the first wind-borne spores, the island starts to fill out and welcomes its first visitors. Birds are the direct descendants of the dinosaurs. No one can say how they survived, but their feathers surely help them to cope with climate changes and cataclysms. In fact, feathers are key to the survival and the dissemination of birds and even of plants. Besides providing insulation, they gave birds a chance to reach safe havens. Some found shelter on volcanic islands, carrying seeds in their plumage and guts. Isolated for centuries, remote islands create endemic species. Therefore, most volcanic hotspots have become biodiversity hotspots. Each hotspot has its own food chain. With the absence of predators, some seabirds may lay their eggs directly on the ground. Colonies grow rapidly. The generous volcano gives them lodging and food. Pushed towards the foundations of the volcano, oceanic currents and their rich nutrients bring organic flotsam. In the shallows, such currents and sunlight fuel another thriving community. Some of the ocean wanderers try to latch onto the recently cooled basalt and form colonies. These limestone plates are the first corals, colonies of genetically identical, spineless animals. Each animal creates a skeleton of calcium carbonate. Thus, over generations, their colonies form a gigantic skeleton. Most of these animals rely on microalgae, therefore on sunlight. Corals have been forming colonies for over 500 million years. Today, some shelter over 4,000 animal species. Most of them drifted around the open ocean before settling here. The sun is not the only energy source involved in building this marvelous complex. Another phenomenon makes it possible to go even further in the diversity that gravitates around the volcano. For this coral reef is only a crown of thorns attached to the mountaintop. There is a 2.5-mile void between the surface and the bottom. The hotspot has transformed the underwater landscape. The mountain it has built forms a wall that pushes upwelling currents along its slopes. These currents are loaded with nutrients, minerals, and plankton. Same as around deep water chimneys, they draw in larger predators, the aptly named apex predators. The island volcano has become a meeting place and a rallying point, a magnet for many ocean wanderers. It welcomes castaways from distant shores. But the welcoming party could turn lethal. As it pierces the Earth's crust, magma from the hotspot meets various rocks and melts them. If these rocks are rich in silica and water, the magma could be tremendously viscous, therefore explosive. These so-called strombolian eruptions, named after the Italian volcano Stromboli, are of little volume. However, they can be very long-lasting and create havoc. They grow so large that some of their slopes are protected from the devastating eruptions. Their soil is very rich in minerals, enabling plants to thrive. Among trees, the competition is fierce. Their vertical race for height and light creates a dense jungle. Old cradles are shaped by water and time, but also by gravity. When igneous rocks stop filling the underground magma chamber of a volcano, the floor collapses under its own weight and creates a gigantic cauldron called a caldera. The geological life of the island is a rapid succession of full and empty chambers. Therefore, its land is now a veritable maze of peaks, vents, and canyons. Today, this geologically active island has a name: Reunion. It is only 3 million years old, yet it already reaches nearly 10,000 feet above sea level. It's the highest peak in the Indian Ocean. Its foundations on the ocean seabed are 13,000 feet deep, which makes it a 23,000-foot mountain. It is still fueled by its hotspot. Its youngest crater is called the Piton de la Fournaise. With it, the island keeps on changing and growing. Reunion Island is the latest addition to a family of volcanoes. After appearing in India, the hotspot gave birth to a ribbon of underwater mountains and new islands that stretched for almost 4,000 miles in the Indian Ocean. The hotspot punctured the Earth's crust like a blowtorch, leaving some evidence in its wake. Before Reunion emerged from the waves, there was the island of Mauritius, which is 5 million years older. The farther we go north, the further we venture back in time. The Chagos Islands were created 45 million years ago. Still farther north from the Chagos, another huge archipelago extended almost to the coast of India: the Maldives. These were some of the first islands built by the hotspot. They used to look like Mauritius or Reunion Island. Today, they have been reduced to low-lying atolls. Where did the typical hotspot islands go? What happened to the ash and black basalt? What became of the plants and animals that lived on these isolated oases? They all sank. Once the hotspot no longer supplies its volcano with magma, the island gets eaten away by the elements. The mountain collapses under its own weight. Like a sand castle, it crumbles and disappears under the waves. This is the future that awaits islands created by a hotspot. Ephemeral earthly paradises destined to be swallowed up by the sea. Only the coral reef remains near the surface, building on its own limestone base. The coral's hard skeleton grows and piles up in order to remain in contact with the vital energy of the sun. Thus, in the Maldives, islands are constantly eroding and constantly being formed. Some islands may disappear when the currents change. Others may appear, beginning as sandbanks. Topside, winds turn sand into dunes. The white sand of dead coral replaces the black sand of the volcano. The sunken island then becomes a new paradise for the ultimate ocean wanderers. After the disappearance of giant reptiles, the Cenozoic era, also known as the Age of Mammals, commenced. Freed from the pressure of giant predators, mammals were quick to take advantage of the available space and blossomed. Of these mammals, humans have been the most successful. We are the lucky heirs of that first hotspot which appeared in India. We are planet Earth's new apex predators. These days, the hot spot beneath Reunion Island is no longer truly dangerous. The Piton de la Fournaise's eruptions do not directly threaten human supremacy. But as mankind extends its web, humans find themselves at the mercy of other hotspots that are bubbling beneath the Earth's crust. Reunion is not the only one. The surface of our planet is scarred with the signatures of other hotspots, which, ages ago, triggered events of mass extinctions. On several occasions, parts of the life on Earth have been wiped out, the cards reshuffled, and new foundations laid. The creation of a new hotspot in Siberia, for example, is thought to have destroyed over 90% of the Earth's species some 250 million years ago. Others have created the island chains of Hawaii, the Galapagos, the Canaries, and Cape Verde. And they all caused chaos on Earth.